Hello and welcome to the Casual Engineers Show. Tonight we're going to have a look at a couple of people who just love making circuits that are dangerous, but they keep producing them. And these all now come under the title of Dukes of HAZZARD. Seems an appropriate way to put it. So let's start having a quick look at what we've got. We're starting with a design by some people who call themselves Creative Techos. Let's have a quick look at the browser piece of this and give me a sec to make sure I pick it all up correctly. Resetting stuff usually takes a bit of time. We go beautiful. Moving along. Just starting with the channel that we're talking about. Just bump the speed up a bit. Now, I'm aware I've had some problems with my audio, but I think I've fixed some of that by now. Let me know it's not right. When you watch what these guys do, you can kind of see that they show you the components. Again, it's an air circuit. A lot of professionals just do not like these kind of circuits for simple reasons that are unreliable. When I get my little corner tidied up in front of my workbench, I'll start demonstrating this. The fact is that build things for the time to experiment. I get that, I used to do that myself. But there are some things that you should never encourage people to do, and I kind of think this is one of them. I'll spin it up a bit and I'm going to go a little bit faster again. You can see he's got a negative positive. One of the things that I did note in the thumbnail, the claim was that this thing...
For easy sourcing of components, visit quadpointtechnologies.com. Here you will find every type of components like ICs, resistors,
and lousy.
Manufacturing defects.
Right, now this is... At least give you a schematic to work with. Boy, this just goes through so quickly. They literally flashed up the schematic and was just gone.
20 days warranty for components against any manufacturing defects.
There it is. And this is one of the few times I've seen them give us this. I do appreciate seeing one, but also captured the thumbnail just so we can have a closer look at this one. So let's have a quick look and see where we're at. Okay. Hello, my bit rate's gone off again. Nothing's dropped, it's giving me an indication. Right, so let's move along now to my next component, which basically is the schematic itself. Now, one of the key things I run into when I'm dealing with schematics is quite often there are claims made, and this one in particular has just made some of them. Just made a couple of items made me stand up and go, well, something's not right here. So here we go. I'm just going to go into this little tool now and start scratching away. You might notice I do tend to like scratching away a little bit because that's where the real fun is, just scratching away. Okay, number one. Let me just fix the colour up. I do like having colour because these things are so much better with a bit of colour on them. Number one. AC. There is no fuse, neither of these leaks, there's no filtration. We're just missing some core components to make this a much better circuit to deal with. That's a 1 meg. Yes, I know I can read my colours still. That's 220 ohm. Now the capacitor here, 105. 105 will be 50 farads, so it'll be about 0.11 microfarads. We basically have a circuit that tries to use the capacitor to divide with this capacitor here. But here's the claim, 3 volts, 6 volts, 4 volts. I've got to tell you, I'm very dubious. What have we got here? Okay. This resistor is there to discharge that capacitor. This is something which I think a lot of people really miss when looking at these things. They kind of don't realise that the mains physically comes in and through the capacitor, through to this point here, and 240 volts goes on this wire, and when the phase changes, it goes down this path. So active connects to this one, and active connects to this one. Very easy to miss. I think the people that I've met over the years just totally missed the point. I think this is a swirly, pretty, yeah, it is. So let's just change colour a little bit. We're just going to have a quick look. How would this regulate? Okay, there's nothing here to enable any regulation. To claim these voltages and to show the diagram and say, oh yeah, but we're doing this, we're doing that. You're not. You have not got any regulation. You cannot expect this to be a genuine regulator with this range of voltages without an active component. So this is passive only. Straight off. It's a passive circuit. It has no regulation. It has no input safety. And basically, if this capacitor gets punched through, that divider formed by this capacitor via the diodes onto the next capacitor is destroyed. That's pretty much it. That's what will destroy it. This one over here, by the way, is a 330 ohm. See a bit of my chat. I can't tell anyone's interacting with me yet. So guys, if I'm not reacting, just let me know. Yeah, I can see that as I've got to do a little bit of filling with my OBS again. There is something there I just can't see you. Just going to take the chat out of this so I can see it. There it is. Echoes, really. It's interesting. I've got everything through headset, so there shouldn't be anything echoing, but I'll look at that. Oh, hang on, there's a bug with some YouTube stuff. Is the echo still there? Yeah. Hey Tony, Captain, how are you? Yeah, look, if this is still echoing, let me know. I want to see if I can fix it up. Back to what I was talking about. Yep. Lacking anything to regulate, you just can't expect the circuit to work properly. So guys, I do apologise for the audio quality. Remember, Huge Ass had some problems with this system would actually echo pretty badly, like a train station. Eh? Okay, so why would I have echo? There is a possibility. Yes. I love technical challenges. I do. I really do. I've got a phone there. I've got a second microphone behind it. That's possibly what's happened. Has that cleared up that echo? Just let me know in the chat, please. Right, I think there's a delay, so I might not hear you straight away, or might not see you straight away. If you're stuck, give me, just find me on Discord. I'm on MT2 and FTFE. You can let me know through there as well. Hey, Sable Eagle. Yeah, exactly. No step down, no regulation. There's no safety on the inputs. So I've got a few complaints with this circuit. If this capacitor gets shorted, the mains now go straight down to this one, so it's blown that one up. The current will probably kill these if that goes short circuit. Basically, this is a death trap, waiting for people just to touch it the wrong way. Yep, it was that. In fact, that second mic. Who'd have thought? Stupid machine. I've got a nice big screen and nowhere to put anything. It's terrible. Yeah. So I say, well, yeah, you made a very good point. Yes, it is absolutely imperative that you have something to step this down. Switch mode power supply, there's no fuse, no regulation, nothing. But I keep seeing these circuits popped up, and they're coming in from a very similar group of people. Just constant. They just produce these things, put them out there, and there's no talk about how safe they are. And you know, if you've got any electronics background, you know that this is quite dangerous. Yep, but I agree. This doesn't step down. One of the things I did catch, and I think it was this particular one. I'll just swap back over to the Chrome share because I think this one's fairly important to look at. This one, that's better. So we'll just go back to this one here and have a look. These guys have fairly built this thing, and yeah, this is the one I saw. There was a claim of no shock. How's that? How about that? Isn't that a perler? My thoughts exactly, Sable. Thank you so much. It's nice of you guys to drop in, and I do appreciate a bit of interaction. I wasn't expecting this many people tonight, especially given a very short notice. But yeah, that no shock, that worried me immensely. I went, hello, why is he saying no shock? Perfect. Thank you so much. I've been setting this up for a number of weeks, and I'm sort of slowly getting there and making things vastly improved. But yeah, this bothered me, the fact that he actually wrote the word no shock right there, claiming that if you touch it, you got no shock. Definitely don't believe that. And by the look of the things, my audience also agrees with that as an assessment, because it simply just doesn't produce what the person was saying. Okay, I will fix up my transitions. I'll be cleaner and a lot neater in the next couple of weeks. Okay, yeah, I do not believe anyone says you don't get a shock from this. Right, what I work out, 0.1 mic, that one's 47. Right, this is trying to use a capacitive divider. Sorry guys, my handwriting is shocking. You could probably understand the chicken better than my handwriting. No protection. And I do apologise, my handwriting is getting worse as I get older. Yeah, he's hoping these resistors here, the 1 meg, will provide you with some resistance, but every time you put your fingers on there, all you're doing is taking what the capacitor is not letting through and just dropping across that. Again, big enough voltage on those little metal oxide film resistors, and they're stuffed. Absolutely stuffed. So that will go, you get the wrong kind of circuit on the other side, that would go. So let's have a little look, see. I think that we could make some improvements. Let's go and get myself a nice new whiteboard. Now let's have a quick look at what we could do. Audience participation, if you guys have got some ideas, yeah, please say so. Yeah, the first thing that really jumps out at me is very, very simple. You guys all said it, you need a transformer. The secondary thing is, do you want a lot of switching? Do you want a large range? A lot of professionals in the day when I did this kind of stuff actually built switched systems, so you could switch between the taps of your transformer, a bit like this. Then they would run this off to inductor, capacitor, and if you wanted to go a bit further, of course, you would then put a regulating component in here somewhere. I just happen to be using an NPN transistor, but that could be anything. And of course, this goes off to some kind of voltage reference, so you can get regulation. You want to get really fancy, you put a hey Captain. Yeah, well, I studied electronics from about the age of 12. Electrocuted myself a few times. I've had, scars on one of my fingers from it. If you want to get really fancy, you also include feedback that you could then use to give you a current regulation as well. Oops. Get back to current regulation, and then you could actually have that feedback into there, and you would have a constant current, constant voltage supply. I've super simplified how this works. I know what I forgot. There's supposed to be a rectifier in there, but that's all right. Yeah, it's been a while for me as well. I did come across someone who had a couple of ideas about what they wanted to do, and they produced what they thought was constant current technology. And I looked at it and I went, oh, I've got some news for the young fella. He put an inductor, another inductor, and then a resistor in parallel, followed by a couple of components and another inductor going out. And he thought this was constant current. So I go back a wee bit with some of the stuff, and it's actually not that hard to do. So many people miss out. So Tiny Captain, this might be really useful to you. We're just going to start with a very simple constant current source. Okay, I do tend to use the squiggles for resistors. And yes, I've been practicing this diagram, so I kind of really got my hand in for this one. All right. And the math for electronics is also fairly simple as well. Since I've got an audience, I might as well talk to you guys about what this is going to do. Theoretically, this should be a voltage divider, and all you do is you set the voltage here to a particular value. You know the voltage here will be, if this is the V reference, then VE will equal VRF minus around about 0.6. It depends on the transistor, how it's constructed, but that's primarily it. You also need a small resistor here. What you're trying to do is get the IR drop here such that I will equal constant. And this is how you get current regulation. This load is allowed to vary. So let's try something experimental. Let's say that the load is allowed to vary from 2 ohms to 200 ohms. And the current that we want to say is constant, we'll actually set that to a value of 0.1 amp, right? So 100 milliamps. At 100 milliamps, 2 ohms will only drop 0.2 volts, and that's across the load. So that's RL. And at 200 ohms, it will drop 20 volts. So the first thing we've had to do is establish what is our minimum power supply required here. Well, it's going to be close to 21 volts. Rough guide. The trick here is that you want the constant current, so what you have to do is set this voltage and this voltage up. So this emitter base circuit does all the regulation work, and it varies the voltage across itself to take between 20 volts, work its way down to about 1 volt. That's how you get a constant current circuit. And you can see there's an active component in the form of an NPN transistor. You can use any transistor you want, but you need to be aware of maximum voltage versus the current and work out the wattage that thing's going to dissipate. It's actually going to dissipate around about 2 watts at that rate. How's the audience going, by the way? I think I turned off the delay, so you guys should be coming through live and pretty quickly. with a digital microscope, and it's got almost the same lead as the other device, so no wonder. Okay guys, I've covered off what I wanted to talk about tonight on this particular thing. I do believe that this kind of is worthy of this one little word from me. New improved snake oil. People do these circuits, they don't do a good job of them. Okay, well, back to me again, and I'd just like to thank all of you for dropping in and saying hello. Please do leave comments below in the video when it comes out, when it finishes publishing. I'm going to sign off because it's 10:21 my time, PM, and I've enjoyed talking to you all. Have a good night. Thanks for coming.